Here's a clip from a lecture on how to solve a Wheatstone bridge for capacitors and for capacitors and resistors together in the same Wheatstone bridge. So we're starting off with this example, circuit A, circuit B. What must be true if the voltmeters read 0? We had kind of a formula for this before. For circuit A, with the capacitors, it was that C1 times C4, right? The diagonals times each other, is C2 times C3. So if you plug in your values, right, this is 4, C4, that's what we're looking for, and this is 3 times 8. So C4 ends up being 6 microfarad. These are all microfarad, right? And then for B, it was the same kind of thing, right? The diagonals R1 times R4 is R2 times R3. The product of the diagonals should be the same. And so what we end up with here, plug in the numbers, so it's 4 times R4 is 5 times 20. It's 100 divided by 4 gives you 25. These are all just regular ohms. Okay, but now what about example 2? In example 2, we've got kind of a new situation. We've got 2 capacitors and 2 resistors. Okay, so let's label these correctly. R1, R2, we'll call this C2, and C1. So what are some things that we know? We know that the potential on capacitor 1 is equal to the potential on resistor 1. These both have to be using up the same potential difference, right? And then the voltage on capacitor 2 has to be equal to the voltage on resistor 2. Because these 2 capacitors are in series, I know that Q2 is equal to Q1. And because these 2 are in series, I know that I2 is equal to I1. This is for the capacitors. This is for the resistors. Okay. Now, V is given by, for capacitors, Q over C. Okay, so this is Q1 over C1 is equal to, now V is given by IR, right? So this is going to be I times R1, I times R1, and the same thing is true for, and this charge is the same here, so that could be just the same. And then Q over C2 is equal to I times R2. Okay, and so these I's are the same, so I can kind of solve these here. So this I would be Q over R1 C1 is equal to Q over R2 C2. But the charge is the same also, right? So these cancel out. So now R2 C2 is equal to R1 C1. So we end up with this kind of thing. And now notice this is different. This is not the product of the diagonals. It's the product of, the 2 top ones equals the product of the 2 bottom components.